Hi everyone and welcome to this DSA Mastery course lecture on recursion, and there will be a lot of lectures coming up on recursion, and maybe this part 2 and part 1, this part 2, part 3 will be coming up, and then we'll move on to backtracking. And I had seen that many of the fellows or beginners whenever heard about recursion, they are just afraid about recursion, and many of you they don't understand fully recursion, what actually recursion is doing. As you will only give one simple definition that a function that recurs itself is called a recursion. But it is good, but this will not give you an overview about what is a recursion. So what I've come is to clear all the doubts. We'll start from very basics to an advanced level, actually how recursions are working actually in a problem. We'll solve the various kind of from basics to advanced problems, and I will be also giving you the problems so that you can practice by your own, okay? And so the hints of the problem so that you will be confident in practicing the problem. As a recursion is just a very simple kind of thing because you only have to build the logic and the code will be written along the logic. Okay, so first of all, let's take a look at a formal definition of a recursion. So many of us has told that a function which calls itself is called a recursion or recursive function. This is all the recursion definition is. Many of the books also states that. So it is good. We'll talk about what is the difference. So it is good that a function which calls itself is called a recursion. And a recursive steps like when a function calls itself at that step, and that step is called a recursive state. And the function where the function did not recur or did not repeat itself is called the base case. And you might be thinking, hey Ayush, you can confuse me a lot, like what is this, a base case, what is this all? We don't understand by a definition, we only understand by examples. We'll take a look at examples just in a second. So just remember that the base case term, we'll talk about just in a second. So the more formal definition of a recursion is that a recursion is a method in computer science where the solution of the problem depends upon the solution on the smaller instances of the same problem. What is that? So let's say you wanted to find the sum. You wanted to find the sum of 5. Okay? So if you were given the sum of 4, and if you find just one thing, sum of 1, then you can simply then you can simply add this up and you will get this. Okay? So let's talk about these types of examples, the factorial of a number. Okay, so first of all, we will explore this example and make you understand what this statement actually is asking about. It is just that we divide a large set of problems into smaller set of problems and then recur itself. We'll talk about just in a second. So first of all, let's talk about a factorial because it seems to be very complicated just now. So let's talk about factorial of a number. So first of all, the logic is how do we take out a factorial of a number? As how do we take out? So let's say you want to take out a factorial of 4. So how do we do that? We multiply 4 times 3 times 2 times 1. Okay, so the short form is the factorial of 4 is this, and it's 4 times the 3 times the 2 times the 1. Okay, this is how all it works. So let's say we have a 4 here, n equals to 4, and this is n times the n minus 1, and here 4 equals to 4 times the n minus 1 equals to 3 times the n minus 2 equals to 2 times the n minus 1 n minus 3 equals to 1. So just the same thing has been given here. So the logic here we build that if we take out this factorial means n equals to n times the n minus 1 factorial. For taking out the n minus 1 factorial, what we will do, we will n minus 1 times the n minus 2 factorial. For taking out the n minus 2 factorial, n minus 2 factorial, we n minus 2 times the n minus 3 factorial, okay, and on and on and on. Okay, so this is something we can relate the logic just now. How do we relate the logic? If we find you can see here n equals to n times the n minus 1 factorial. If we take out this, then we will get the answer. Let's take an example that here n equals to 4 times the n minus 1 is 3 factorial. Okay, so how do we take out 3 factorial? For taking out of 3 factorial, we will 3 times 2. Okay, so first of all 3 times 2 factorial. 2 factorial. Okay, and how do you take out a 2 factorial? 2 factorial equals to 2 times the 1 factorial. So how do we take out of 1 factorial? For taking out of 1 factorial, 1 times the n minus 1, which is 0 factorial. So what is the 0 factorial? We know the 0 factorial is equals to 1. So we get the answer 1. So we will give, he is waiting for 0 factorial. So 1 times the 1, because the 0 factorial we got is 1. So it's equals to 2. So now we got, it's 1. So 1 factorial equals to 1. Now we got. Now the 2 factorial is waiting for 1 factorial. So we will give out here, and this is 1. So 1 factorial we have find out, and then 2 times 1 equals to 2. Now we have 2 factorial. Now this is waiting for 2 factorial. Then we give up 3 times the 2 factorial. It is 6. Okay, so we have a 2. Okay, so it gives us 2. 3 times 2 equals to 6. Now we have a 3 factorial. Now this is waiting for 3 factorial. So we'll give out a 3 to 4. 4 times the 3 factorial. 3 factorial equals to 6. So 4 times the 3 factorial equals to, I think, 4 times the 6 is 24. Okay, so this is 24. Okay, so this is how the recursion is. Okay, so understand what is happening here. What we are doing is that this is paused for this is paused for this, and this is the base case where we don't require anyone. This is the base case where the function did not require anyone. Okay, and the reason why they did not require anyone, because we all know that a 0 factorial equals to 1. Okay, so we'll use a if n is equals to 1, we'll return 1. So let's talk about how do we code, and let's understand in more better way. Okay, so for coding it, let's say we have a function factorial. We have a function factorial which takes an integer n, and we check whether the number is equals to 0. If it is, then we'll return 1, because the 0 factorial equals to 1. Okay, otherwise if it is not, then we will return n times the n minus 1 factorial. So we will make use of factorial here. Okay, so we will again call this function n minus 1. So let's understand actually what is happening here. Okay, in this code. So what is happening? You can see here that let's say we have given n equals to 3. N equals to 3. So it checks 3 is equals to 0. So it's not. So it goes to else part. So here 3 times the 2 factorial means n minus 1 means 3 minus 1 factorial. It wants. Okay, so it again goes up. It again goes up because again we are calling the same function factorial of n minus 1. So it again goes up. Again goes up. So it is now it is 2. So oops. Okay, so let's try the function. So what is happening? So we have written the code once again. So what is happening? What is happening is that let's say we are given n equals to 3. Okay, so 3 is not equals to 1. So what is this? Goes to else statement. So now 3 is here, n equals to 3 times the factorial of n minus 1. Now it wants the factorial of n minus 1 here, n minus 3 minus 1 equals to 2. So it wants the factorial of 2. So now it wants the factorial of 2, so it again we are calling the same function, but it is different function. Either it is the same function, but it is a different function. So now n equals to 2. So now n is equals to 2. So what is happening is now n equals to 2. Now it checks if is n, so here it will be 0. Okay, so it will be 0. So it checks n equals to 2 and n is equal to 0. No, absolutely no, it is not equal to 0. So it goes on else statement. So 2 times the factorial of 2 minus 1. N minus 1 is here, now n equals to, so we want the factorial of 1. Okay, so for taking out again the factorial of 1, now n equals to 1, so again it goes up. Now n is not equals to 0, so it goes here and it checks n times the n minus 1 factorial. So 1 times the factorial of 0, because 1 minus 1 equals to 0. Now when it goes here in its if statement, it checks 0 is equals to 0, because we are calling out factorial equals to 0. So it goes up and it checks that. But this is where we found that 0, the factorial of a 0 equals to 1. Now we got the factorial of a 0. Now factorial of 1 is waiting for that. Factorial of 1 is waiting for that. We will give them. Now we got factorial of 1. Now we will 1 times 1. Now we got 1 factorial, so we'll give it here. Now we got 2 times the 1 factorial, so we have 2. Now we have 1, now we'll give to this one because it wants 2 factorial, so 3 times the 2, now we got 6. Okay, so this is how all the things works. Again, I will be explaining you. So first of all, let's write the code, because you will be getting a notes regarding the same. This is a very good notes. Okay, so I will highly recommend to, after this lecture, just revise the notes, do some problems, and you will be good to go. Okay, so let's solve some problems and let's try to understand in our code. Okay, so I am in my Factorial. This is a Java file. This is a Java file, and let me make a function which is a factorial. So it's a factorial, let's say a static integer, because it gives us integer factorial, and it takes the input as a number, parameters, and then we will check. This is the base case. The reason why we have, first of all, let's assume that we don't have any kind of base case. Let's leave that. So what is here which is happening? Return, we are simply returning n times the factorial of n minus 1. Okay, so let's save this. We'll make you understand just in a second. Just wait for a minute. Factorial, let me system that at that println the factorial of, let's say, 4. Okay, so it should give us 24. So when I save this and when I run this, it will give us what it will give is a Stack Overflow. It is giving us an error. The reason why it is giving us an error, so let's try to understand it a little bit more, why it is actually giving us an error. Okay, so what we have, the code we have written is that we have our factorial, our favorite factorial function. So we have a factorial. Let me choose a white pen so that it looks good. Okay, so we have a factorial which takes input n, and it simply return the n times the factorial of n minus 1. This is what it's doing. Okay, so this is what the function is doing. So let's say our factorial n is, let's say 3. Okay, so n times, so 3 times, now n equals to, when n equals to 3, so and 3 times the 3 minus 1, which is the factorial. Now we want the factorial of 2, because we want the factorial of 2. Now it again goes up, now it again returns the 2 times, now n equals to 2, now n equals to 2 because we want the factorial of 2. So, and here 2 minus 1 equals to 1, so we want the factorial of 1. Okay, so now n equals to 1. Okay, and then we now for n equals to 1 we n minus 1, so 1 times the 1 minus 1 equals to 0 factorial. Okay, now we want 0 factorial, but we go up, there is no any kind of f, so we'll make use of n equals to 0. Then again what we will do, 0 times the 0 minus 1, which is minus 1 factorial. For taking out the 9 minus 1 factorial, what we will do, we will n minus 2 factorial. So n equals to minus 1, so minus 1 times the n minus 2 factorial. So it is minus 2 factorial. And it goes infinity times. And you know that our computer doesn't have that much memory. Whenever you run a while loop or infinite while loop, you will get a stack overflow error. Means you have consumed over limit memory, and the Java will not allow to do that, or any programming language will not allow to do that. This will give us an error related to in Java. It is stack overflow. It may be in kind of any other edge, maybe a storage full or something like that. Okay, so that's why what we will do, we will make a base case where we know that now this is over. So the base case is, we will integrate here, if the n equals to 0, then we will return 1. So here you can see that here n equals to 0, n is equals to 0. Now we know this is 1, so we have a factorial of 0, we have a factorial of 1, now we got the factorial of 1, so this is waiting for factorial of 1, so we give the factorial of 1, which is 1 time, because 0 factorial is 1, so 1 times 1 equals to 1, so it gives us a 1, so now we know 1 factorial, so this is now this is 1, so 2 times 1 equals to 2, now we know 2 factorial, now this is waiting for 2 factorial, so now we give this 2 factorial to him, so it is removes, that is 2, so 3 times 2 equals to 6, and we are good to go. Okay, and this is called the base case, where our function, where we know where our function did not recur, or this is the very base case where it is not where it is, what I can say, where the function is not recurring. You can see here that is 0 factorial recurring. No, we have set it that if n equals to 0, then we return 1, because we know that. Okay, pretty much easy. In 18 minutes we understand the recursion. Understand that in a very easy way, in a very formal way, we have understood the recursion. Okay, so let's code this, let's code the good thing, and let's understand the thing by code. Okay, let me make now what I will do, I will check if n is equals to 0, then what I will return, the 1. Okay, so I'll return 1, else what I will return, n times the factorial of int n minus 1. Okay, pretty much easy. I've already explained you all the factorial, and on whole YouTube I find not a good instructor who is teaching in this way. Okay, but the criteria is you should know English. Okay, so I think you have understood it a little bit more intuitively. I have explained you 2 times now. It may be 3 times. Okay, so if I save this, if I run this, it will give us 24. Okay, so we had a very simple code, a very simple logic has been used here. Okay, pretty much easy to understand the recursion. So in the next video, I'll be bringing up one more kind of tutorial on a function, on again a factorial, again a recursion part 2. Okay, so stay tuned for the next video. I'll be meeting on the next video. Please hit the subscribe button, and meet you in the next video.